Good morning class. Today we are going to discuss about the DC machine. So in the field of electrical engineering rotating machines, the machines can be classified into two categories. One is the DC machine and second one is the AC machine. So in this class we are going to discuss about the DC machines. So in DC machines we have mainly two parts. One is the stator, one is the rotor. Over the stator we have poles and we have one winding that is known as the field winding, and second one over the rotor, that is the rotating part of the machine. There we have the slots. Over the slots we have the rotor winding, that is namely armature winding. Now the depending upon the nature of input and output power of the DC machine, it can be again classified into two categories. What are the categories? The categories are DC generator, DC motor, depending upon the input and output power. Now if we give electrical energy input at the stator part, that is on the field winding, and if we take output as a mechanical energy from the rotor, then we can say it is acting as a motor. Now if we give mechanical energy as input in the rotor section, and if we take output energy as electrical energy from the stator or the field winding, then it is acting as a generator. So in this particular class we are going to discuss about the DC generator, and in DC generator we will discuss that what are the constructional features we have, that is the parts of DC generator, the stator section, the poles, the field winding, over the rotor, what are the windings we have, that is the armature winding, what is the cover or the yoke of the system. Then we have the brush, the commutator section where the AC power is converted into DC power, that we have to discuss in this class. Now after the construction features study, then we have to know that what is the working principle of DC generator, then we have to know the EMF equation of the DC generator, then we have to go for the armature reaction, what is the concept of GNA, what is the concept of MNA, then what is the commutation, how we can improve the commutation, then we will go for the different types of DC generator we have. That means separately according to the excitation we can say that two types of generators we have. One is separately excited DC generators, next one is the self-excited. Again, self-excited can be classified into three categories: series, shunt and compound. Again, compound can be classified into two categories. What are the categories? The categories are the long shunt and short shunt compound DC generators. So that we have to discuss over here. Now after doing that, what we have to do, we have to know the different characteristics of separately excited DC generator. Next we have to do the characteristics of series shunt compound generators. Then we have to go for the voltage regulation, and the last part is this of this discussion is that what is the application, daily life application of the DC generator. Okay, thank you.